Let's say 100 divisible है. So, good evening, all of you. So, in this practice session for PGT Physics exam, we are discussing the current electricity chapter, and I have discussed few questions in last lecture. Now, let's start with question number. This is the summary part. Let's see the questions. I have given you that you have to solve this particular question. It's easy, you can easily solve. Now let's start with question number 12. See question number 12. So in this question, it is given that there is a 10-volt battery and it has negligible resistance, and it is connected across a diagonally opposite corners of a cubical network consisting of 12 resistors, and each of resistance is of 1 ohm. This is given. Determine the equivalent resistance of the network and the current along each edge of the cube. So what will be the equivalent resistance of the network between these 2 points? Because between AC, because voltage is applied in between AC dash. So if you see the symmetry of this circuit, I have assumed that this total current is 3I. Why I have taken? Because they are of equal resistance. So you can apply KCL at this node. So there will be current I, and I. So that this current is 3I. Now at this edge, this current I will be dividing into 2 branch. So current will be half because of equal resistance. So this is I by 2 and I by 2. And at this particular branch also current is I by 2 and I by 2. So at this edge, I by 2 plus I by 2 will give you I. Here also you have I by 2, I by 2. So this will give you I. This current is also I. So again, this current will be 3I. So because of this symmetry, I am assuming this current is 3I. So how to find the current? Let's see. I'm taking this particular loop, A, B, C, C dash, E, and A. Consider this particular loop and try to apply KVL. Let's see question number 12. So I'm considering a closed loop. Consider a closed loop. So let's see, this is A, then B, then C, then C dash. Again, you will return to the battery E and A. And you know that what will be polarity of the current? So if in a particular resistor, current is flowing in this direction. So this will be at higher potential, this will be at lower potential. Let's say this is R. And if you have a battery, this is minus, this is plus. So when you apply KVL in that loop, you have to consider the sign convention also. That sum of the voltage in closed loop, algebraic sum of the voltage in closed loop must be 0, considering same sign convention. So I'm assuming whenever you are moving from high potential to low potential, because this is the direction of current. So this is at higher potential, this is at lower potential, and assume its resistance is R. So you will write it as, I'm taking it as plus I into R. This value plus I into R. Then this will give you plus I by 2 plus I by 2 into R. Again this is I into R, I by 2 into R, and this will give you I into R plus I into R. Then if you return to this voltage, you are moving from minus to plus. So this is minus 10 volt is equal to 0. So this is by applying KVL. I have applied KVL, is Kirchhoff's voltage law. That sum of the voltage in any closed loop must be 0, considering same sign convention or algebraic sum. So what will be current I here? So in this case, if I am taking EMF of the source is E, let's take, instead of writing this, I am taking it as EMF of the source is E. So here EMF is given by what? This is 2 5 by 2 I into R. 5 by 2 in I into R. So what will be equivalent resistance? Here you have to write 3I, because if you assume that equivalent will be R equivalent and EMF is E, so that is E by this current. So what will be E by 3I? So this value is 5 by 2 IR, and this is 3I. So this will give you 5 by 6 R. And here R is 1 ohm. So this will be 5 by 6 ohms. I have taken R is equal to 1 ohm. This EMF I am taking as E. So now equivalent resistance will be 5 by 6 ohms. So that is the equivalent. And find and the current along each edge of the cube. So what will be current? Current will be given by, what will be current? 3I. 3I is E by R equivalent. E is equal to 10 volt. And this is 5 by 6. This will be 12 ampere. So I will be given by 3 ampere. I is 3 ampere. So now you can see current along each edge of the cube. So if you know this current, so at each edge, you will see how current will be divided. So at if 3I is 12, so this current will be what? 3 ampere, 3 ampere, 3 ampere. This will be 1.5, 1.5. So just because you know I, so at each edge you can write the currents. Is it clear? This will be 3 ampere, I by 2 will be 1.5 ampere, and so on. So whenever there is a symmetry is involved, using this, you can find the equivalent resistance and then you should find the current also. So this is based on KVL, KCL, and equivalent resistance. Now see next question. Again, it's based on KVL and KCL. Let's see. This particular question. Determine the current in each branch of the network as shown in the figure below. So in this figure, this current I have assumed, let's assume this current is I1 is given. Then I have taken this current to be I2. So this will be I1 minus I2. So this is I2. And I have taken, let's say this current is I3. So current here is I3. This will be I2. So this is I2 plus I3. This will be I1. So this is I2 plus I3 minus I1. So at each node, I have applied the KCL, Kirchhoff's current law. Sum of incoming current is sum of outgoing current. So you have to find these currents. So there are three unknowns, I1, I2, and I3. So we need to set up three equations to find these values. So let's see how you will find. So consider let's see question number 13. Consider a closed loop let's say this loop ADCA and apply KVL, and then you should apply KVL. So if you write this, there is a 10-volt battery here. So I'm taking ADCA. So this is minus 10 volt. Then because this is, I'm taking this to be higher potential, this is low potential, this is the direction of current. So then minus 4 I1 minus I2 plus 4 I1 minus I2. Then you have minus 2 because you are moving in this direction, I2 plus I3 minus I1. And then this value is plus 1 into I1. Plus 1 into I1 is 0. So now you should rearrange this particular equation. So if you write this, this is 4I1 plus 2i2 6 plus i1. This is 7i1. What about I2 minus 4 minus 6? So this is minus 6 I2. And then I3 is minus 2 I3. This is equal to 10. So this will be equation, take it as equation 1. Clear? Now you have to set up another equation. And let's see this particular A, B, C, A. This loop I am considering because we need 3 unknowns. So you have to set up KVL in 3 loops. Now, for closed loop, A, B, C, A. Again, if you apply KVL, so that will give you A, B, C, A. You have 4i2 plus 2i2 plus i3 plus 1 into i1 minus 10 volt is equal to 0. So this equation will give you i1 plus 6i2 plus 2i3. Again, this is equal to 10. So this will be equation 2. So this is loop 1, loop 2. Now take another loop. Let's see. I'm taking this particular loop, B, C, D, and E, B. Let's see. For closed loop, B, C, D, and then you have epsilon B. Again apply KVL. Again apply KVL. So you will get 2 I2 plus I3 because this is the direction of current. So current is flowing high potential to low potential. I am taking plus sign. So plus 2 I2 plus I3 minus I1. Then minus 5 volt is equal to 0. So this will give you, you should write it as, so this is minus 2i1, minus 2i1. Then you have plus 4i2 and plus 4i3. And this is equal to 5. Now this is equation 3. Now it's a matter of calculation. You have to solve equation 1, 2, and 3 for I1, I2, and I3. Let's solve it. Solve 1, 2, and 3. And write down the values of I1, I2, and I3. Take 1 or 2 minutes and try to calculate. Let's calculate this value. So I think now this question is visible. Is it clear? So let's see. What will be value of I1? If you solve it, I think I1 will be 2.5 ampere. And I2 will be 5 by 8 ampere. You have to check this result. 5 by 8 ampere. And I3 is 15 by 8 ampere. Please check this result. 15 by 8 ampere. Is it clear? So now in different branches, what will be the current? If you know I1, I2 and I3. So what will be current in other branch? So let's see branch AB. In branch AB, current is I2. I2 is 5 by 8 ampere. This is 5 by 8 ampere. Then branch is you have AB, then you have AD. AD is I1 minus I2. This value is I2. AD is I1 minus I2. So I1 is 2.5, or this is 2.5 minus I2 is 5 by 8. So this is 15 by 8 ampere. Then you have, let's see branch CA. What will be current in branch CA? CA is I1. And I1 is, we have calculated 5 by 2 ampere or 2.5 ampere. Then this is CA. We have calculated in this branch. Now see BC. In BC branch is I2 plus I3. So this is BC is I2 plus I3. So I2 will be, I2 we have calculated 5 by 8. And I3 we have calculated 15 by 8. So this is what? 20 by 8. 20 by 8 is 2.5 ampere. Then you have CD. What will be current in branch CD? CD is I2 plus I3 minus I1, and this will be 0 ampere. And then I3 DEB branch. This current will be I3, and I3 is 15 by 8 ampere. So again, using KCL, KVL, you can find the current, and then you can see current in each branch. Is it clear? So note it down. Now I will see next question. Let us first see the question. Let us see this particular question. Question number. First note down the question. So the form, it's based on Wheatstone bridge circuit. The 4 arms of a Wheatstone bridge have the following resistance. This is given. AB is 100 ohm, BC is 10 ohm, CD is 5 ohm, and DA is 60 ampere. A galvanometer of 15 ohm, this galvanometer resistance is 50 ohm, is connected across BD. And this EMF is 10 volt. Calculate the current through the galvanometer when the potential difference of 10 volt is maintained across AC. Is it clear? Let's find the current through the galvanometer. What will be the IG current? So now let's see what you have to find. You have to find current through the galvanometer. So assume this current in the circuit is I, and this is dividing between at this node I1 and I2, and I'm taking this current to be IG. So at this point, this will be I1 minus IG, and this will be I2 plus IG. And again at this node, you will get current I1 plus I2 is I. Yes or no? So let's see. So let us first consider, again you have to find IG here. Let's see how we'll calculate IG. So this is question number 14. Consider this portion BADB. Consider BADB. Consider loop BADB. BADB. So what you will get if you are moving in this direction, so this is lower potential, this is at higher potential. So this is minus 100 I1. Then this will be plus 60 into I2, plus 60 into I2, and then this will give you minus 15 into IG. Minus 15 into IG is equal to 0. Or this can be written as, let's divide it by 5. So this will give you 20 I1 plus 20 I1 plus 12 I2. This is minus 12 I2 minus 12 I2 plus 3 IG is 0. So this is equation 1. So this is one particular loop, BADB. Now I'm considering second loop. Let's say BCDB. Consider loop BCDB. I'm applying KVL in each case. Algebraic sum of voltage in any closed loop must be 0. And I'm considering the sign convention. Whenever you are moving from higher potential to lower potential, I'm taking plus sign. And when you are moving from minus to plus, you are taking minus sign. Now you have BC, BCDB. So let's see, BC is plus 10 I1 minus IG. 10 I1 minus IG. So then you have minus of 5 I2 plus IG. And then minus 15 into IG is 0. So this will give you 10 I1 minus 15. This is 10 IG. So minus 30 IG. Minus 5 I2 is 0. Or this will give you, divide by 5. So this is 2 I1 minus 6 IG. And then minus I2 is equal to 0. So this is equation 2. This is equation 1. And this will be equation 2. Now we need another equation. So I'm considering, let's see this outer loop, ADCEA. That includes the EMF also. Now for loop, ADCEA. If you apply KVL in this loop, this is 60 into I2 plus 5 I2 plus IG minus 10 volt minus 10 is equal to 0. So this will give you, this will be 65 I2 plus 5 IG, and that should be equal to 10 or divided by 5. So this is 13 I2 plus IG is equal to 2. This is equation 3. Now from these three equations, we have to find IG. We have to solve for IG. So how you will get IG from this equation? So if you consider these three equations, you can solve for IG and then for I1 and I2. So what you have to do first, you should, from these two equations, you should eliminate I1. So you will get equation in terms of I2 and IG, and then you should solve equation 3. So it's a matter of calculation. If you solve this equation, you will get IG is IG will be given by, I think this value will be 4.87 milliampere. If you calculate the value of IG, this will be 4.87 milliampere. You can easily solve. First, eliminate I1, you will get I2 and IG, and then with equation 3, you can solve. I'm giving you the answer, you should solve it. This is 4.87 milliampere. Clear? Means in a circuit, by applying KCL and KVL, you can get the current, and then you should see what will be the voltage drop also. If you know current, if you multiply with resistance, you will get the voltage drop. Clear? So that is application of KVL. Now let's see next question. There is another question that you have to solve. Determine the current in each branch of this network. Let's see how we will solve this question. Determine the current in each branch of the network. I will write the equation and then you have to solve it. So let's see. This is question number 15. Question number 15. So let's take this point is D. This point is D here. So consider these are the points A, this is B, C, and this is D. This is one resistance. There is another resistance. And then this is 5 ohm and this is connected with 1 ohm. This will be 10 volt. This is also 10 ohm. This is 10 ohm, 5 ohm, 5 ohm, 10 ohm, and 5 ohm. Now see what will be the current that is flowing. So I am considering this current to be, let's say, I1. And let's say this current is I2 and this current is I3. So this is I1, I2, I3. I am taking this current to be I4. So what will be this current? I2 minus I4. So there are 4 unknowns. And at this node, what will be this current? I3 plus I4. And then here I1 is I2 plus I3. So in this also current is I1. This current is I1. So show the polarity plus minus. I am showing the polarity plus minus, plus minus. So again, by applying KVL, we can find these currents. So let's see how we will calculate. Try to solve this question. Now, if you have ABDA, now I'm considering first ABDA, this particular loop. ABDA. So you will get 10 into I2 plus 5 into I4, then minus 5 into I3 is equal to 0. So this will give you 2I2 plus I4 minus I3 is 0. So this will be equation, or this will give you I3 is 2I2 plus I4. 2I2 plus I4. This is equation 1. Now you have second loop is, let's say BCDB, this loop, BCDB. Consider the loop BCDB. Try to apply BCDB. So BC is 5, I2 minus I4. This is 5, I2 minus I4. And then minus 10, I3 plus I4. And then you have minus 5 I4 is equal to 0. Let's simplify this expression. And if you simplify it, you will get I2 is twice I3 plus 4I4. Let's check this equation. This will be equation 2. This will be equation 2. Clear? And one relation is I1 is I2 plus I3. We have to use this particular relation also. Now I will take another loop will be, let's consider A, B, C, E, A. So you will get this. So let's see A, B. I'm taking A, B, C, E, A. A, B, C, E, A. E is for battery. So now see, first you will get 10 I2 plus 5 I2 minus I4. So this is 10 I2 plus 5 I2 minus I4. Then minus 10 plus 10 I1. So then you have minus 10 plus 10 I1 is equal to 0. And if you simplify, you will get 3 I2 plus 2 I1 minus I4 is equal to 2. So this will be equation 3. Now you have 4 equations. These 3 equations plus I1 is I2 plus I3. So using these, you have to solve it. So let's try to solve it. Take 2 minutes and try to solve it. Try to solve it. So let us first solve equation 1 and 2. Solve from equation 1 and 2. What you will get from 1 and 2, let's eliminate I2, put I2 in this equation, and then you will get relation between I3 and I4. So from 1 and 2, you will get this relation. I am giving you the result. You should verify. I3 is minus 3I4. This will be equation 4. Then from 1 and 4, you will get an equation. I2 is minus 2I4. And then you should use this equation. Since I1 is I2 plus I3. Use this equation. So if you use I1, I2 plus I3, and if you solve it, finally you will get I1 will be 10 by 17 ampere. You should verify this result. And I2 will be given by, let's check what will be value of I2. I2 will be 4 by 17 ampere. I3 will be, you have to just check these values, 6 by 17 ampere. And I4 will be given by minus 2 by 17 ampere. Just see, in case here, initially you can assume any direction. If you are getting answer is positive, then assume direction is the actual direction. But when you are getting negative sign, magnitude will be same. So only thing is I4 direction will be opposite to this direction. So I4 I have assumed this direction. So actual direction will be opposite to this. But magnitude will be same. Magnitude will be same value. 2 by 17. Only thing is direction is opposite. So in this way, you can easily apply KVL and KCL to get the current and then voltage across different elements. So in today's lecture, I have just focused on the KVL and KCL part. Now in tomorrow's lecture, we are going to complete this. We will also take some circuit where you have to see the equivalent resistance and EMF related problem that we will discuss in next lecture. Is it clear? So in today's lecture, we have just focused on KVL and KCL in a circuit. Clear? So try to solve other questions also. I will discuss it in next lecture. Clear? Chalo. Okay. Thank you everyone. Thank you.